Now that we had a look at covered queries, let's also see when MongoDB actually rejects a plan. Now, for that, I'll reuse my customers collection from the last video. And remember, there we have two indexes, the standard ID index and our own name index. Now, I'll also add an additional compound index on customers with create index, and I will add age here in ascending order and name. Now, please note that the order here is important for compound indexes. And if I would have put name first, this index here wouldn't make much sense, because then I would have a single field index on name, even though name is the first field in a compound index. And as learned, from left to right, a compound index can be used, well, standalone. So each field can be used standalone from left to right. So in this case, if age comes first, we can also filter just for age and take advantage of this index. For name, we can't take advantage of this index because name is only the second value, is mapped to the respective ages and only sorted within the age category. So if you filtered for just name and you didn't have that index, name could not be supported by index. Here it can, because we have a single field index, and we also get this compound index for the combination of age and name, or just age. So now I create this compound index here, and now I have three indexes, of course. Now let's search, or let's explain. So customers explain. Let's search for all persons with a name and an age. So name may be Max and age 30. If I hit enter, you see, the winning plan is an index scan where it used the compound index, and as I mentioned in the compound index lecture, the order in which you specify your arguments when writing the query does not matter. Our compound index was created with age as the first value and name as the second, and in the query I have name as the first value and age as the second, but here in the query the order does not matter. It still is able to use that compound index because we have a simple AND condition here, and you can of course reverse that, and MongoDB does reverse it for us automatically, so to say. Therefore, the winning plan is an index scan using that compound index. Now what we can see is that we now also have a rejected plan. And the rejected plan was to use an index scan just on the name index. That is the single field name index I created. Of course, it made sense for MongoDB to also consider this, because we have that name index, we had a query that included a search for name, so it made sense to consider that name index. But of course, since we have another index which simply fits this query better, this compound index, MongoDB chose to use this one as a winning plan and rejected this one. Now, this is interesting to know. The question, of course, is how exactly does MongoDB figure out which plan is better? For this, MongoDB uses an approach where it simply, first of all, looks for indexes that could help you with the query at hand. So in our last lecture example, we had the name single field index and age and name as a compound index. Since our query, our find method, included a look for name, MongoDB automatically derived that both the name single field index and the age name compound index could be helpful. So it came up with two approaches. For other scenarios, you might of course have more approaches. So let's say we have three approaches. MongoDB then simply lets those approaches race against each other, but not for the full data set, but it sets a certain winning condition. Right now, that should be 100 documents. So it looks who's the first to find 100 documents. And of course, one of the approaches will be the fastest to reach that threshold. MongoDB will then basically use that approach for the real query. And of course, it would be cumbersome if it would have to do this for every find method, for every query you send to the database, because that obviously costs a little bit of performance. Therefore, MongoDB caches this winning plan for this exact query. So for exactly the query you sent with the fields you are looking for and the values for the fields you are looking for. So it caches this plan as the winner plan for this kind of query. And for future queries that are looking exactly equal, it uses this winning plan. For future queries that look different, that use different values or different keys, it will of course race again and find a winning plan for that type of query. Now, of course, this cache is not there forever. It is cleared after a certain amount of inserts or a DB restart. To be precise, instead of being stored forever, this winning plan is removed from cache after you wrote a certain amount of documents to that collection. Currently, that should be 1,000. So after you added that many documents, MongoDB says, I don't know if the current winning plan will still win because the collection changed a lot, so I should reconsider. The same happens if you rebuild the index. So if you drop it and recreate it, for example. It also gets deleted if you add other indexes, because that new index could be better. So the cache for indexes, or winning plans, I should say, gets cleared when you add new indexes, or when you restart the MongoDB server. Then this also gets reset. So this is how MongoDB derives the winning plan and how it stores it. And it's interesting for you as a developer to regularly check your queries, your find or update or delete queries, and see what MongoDB actually does, if it uses indexes efficiently, if maybe a new index should be added, something you can do on your own if you own the database or you pass that information to your DB administrator, or if you maybe need to adjust the query. Maybe you're always fetching data that you don't really need, and you could get a covered query if you just would project the data you need, which happens to be the data stored in the index. That is why you as a developer need to know how indexes work, because either you need to create them on your own in your next project on which you work alone, or because you can optimize your queries or tell your administrator to optimize the indexes. Now, with that information gained, let's have a look at the last level of verbosity the explain method offers, and that is that we can add all plans execution as a value here. Now what this will do is, it will give us a bunch of output, because here we get detailed statistics for all plans, also the rejected plans. So there we can see in detail how would an index scan on our compound index perform, but then also what would happen if we had that index scan on the name index. How long would that take? How many documents would it there consider? Documents, and how many keys would it consider? How long would it take? Here we have 0 because it's so super fast, but for larger collections you would of course see a difference. And with that you can get detailed analytics on the different indexes and queries and possible ways of running your query, and therefore you should have all the tools you need to optimize your queries and your indexes.